Good morning, everybody. Today I will start lecture on compressors, and it will be including IC engines also or prime movers. Okay. So in short, I'll try to cover in almost 1 hour. Uh, so first, I'll start with compressor. Compressor, I already told that pump and compressor are almost same function. Compressor, you are compressing in pump. Normally, you are not target is not to compress. Although liquid, if you give very high pressure, that will also be there will be some compressibility, but we are ignoring in normal application. But in gas, if you see some small pressure change, the compression will be very high. Uh, so in pumping system, you have seen reciprocating compressors, reciprocating pumps, centrifugal pumps, and other types of some pumps. In compressor system also same thing we can use. Okay, but some extra study you have to do because it is compressible. So compressible means that PV gamma and PV equals nRT. Those formula will be coming here. Okay, and basically this topic you can check in Arnold and Morris book, Surface Production Operation Volume 2, and many other document also you can take. This is basic, so you do not need to go too much in depth of anything. Just some basic knowledge and some mathematical calculation you will try to do. So compressor, why do you use compressor when you are considering? So basically, like gas compression system, you have different wellbore and different pressure you have. So in that case, you have to make uniform pressure or same pressure, then you can inject actually. For example, well 1, well 2, well 3 is there. Okay, and you have common surface facility. You have common surface facility, and let's say well 1 is having P1, P2, P3. Okay, so P1 is having very high pressure, P3 is very low pressure. So if you are not managing this gas pressure properly, what will happen? P1 pressure may enter into gas in P2, or P2 production rate will be lowered because you are not managing pressure. High pressure will be pushing down this low pressure, right? So maybe you have to use sometime booster pump so that all pressure will be equal, then you can have common line and common separator system. But if you have different pressure, even pumping system also same, if one is very low pressure, one is very high pressure, that will be having difficulty in surface production systems. So you need compression systems or pumping system on the surface production systems. In compressor system, many cases you work with low pressure, like say atmospheric pressure. In many cases you work with very high pressure. For example, you are getting LPG, liquid petroleum gas, right? So in that case you have to create liquefaction. So pressure should be higher and temperature should be lower. So that thing criteria should be there. But if you consider, let's say, flaring, so maybe low pressure compressor, other compressor can be used for maybe extracting some gas and putting into some other separator system, and you can reuse. So there are ample application of compression systems in your surface production systems. Gas lifting system, you need to compress gas. Different wellbore, different pressures are there, so you need to use. Again, each separator will have some. If you can remember, each separator will have some gas outlet line, right? Gas means extra gas. So separator 1, separator 2, maybe another is there. Okay, separator 1 may be high pressure. Okay, separator 2 may have much lower pressure. Okay, because each stage pressure will be going down and you cannot connect directly that pressure, otherwise high pressure gas will be entering into your low pressure separator. So you must manage that one using some compression system. Maybe separator 2 will be requiring some compression system or high pressure, creating pressure, more pressure system, right? So that way you have to handle system. So then what are the different options? One, basically two types of compressors will be used: reciprocating, centrifugal. Other type of compressor can also be used, but I am not discussing because of time limitation. So flash gas compressor possible. Okay, normally characterized by low throughput rate and high differential pressure. Okay, low throughput or flow rate and high differential pressure will be the flash gas compressor. Okay. Differential pressure is expressed in terms of overall compression ratio. So overall compression ratio ratio RT, or any symbol you can put, P discharge pressure, P suction pressure. So whatever the unit, you have to make same unit. Okay. So let's say this one PSIA. So this must also be PSIA, because you have to make unitless, because you are saying ratio. So I am not talking about unit. Okay. For for a surface production gas compression of gas, normally RT value will be 5 to 20. So let's say 20 meter cube volume you take, finally it will be 1 meter cube. So that ratio. Okay. So booster compression system, that pressure ratio will be like 2 to 5, lower pressure booster. So you are just boosting some pressure. Okay. RT will be 2 to 5 ratio. So this will be unitless. Fine. So compressor, reciprocating compressor, in pumping system we said like it's a low speed, but in compression system normally you can create high pressure also, high rotational speed, and so high RPM also you can create actually, because multiple cylinder will be there. So you create high rotational speed and total volume flow rate will be higher. Okay. Pressure range may not be higher, but volume flow rate you are increasing, because number of cylinder you are increasing, number of cylinder increasing and number of stroke also increasing, your volume flow rate will increase, because volume flow rate equals ALN, right. So L increase, N increase, A increase, anything you are increasing, Q will be increasing. Okay. So volume flow rate if you want to increase, then number of strokes or RPM of the system you increase, length, stroke length maybe you can increase, total volume will increase, or maybe piston diameter you can increase. That way you can increase total amount of throughput or flow rate, and again you have to check unit every time. Okay, I already told overall compression ratio RT equals P delivery by P suction. Okay, so suction pressure will be more, delivery pressure will be low. So okay, so overall compression ratio you have seen RT PD by PS. So delivery pressure is higher than suction pressure. So it will be like, normally I have written already 5 to 20 this within this ratio, but it will be more or less also based on your requirement. But normal application 5 to 20, and if I ask you to use thumb rule, so you take any value 5 to 20. Okay, if I give some value, then you have to use that one, and in exam if I say okay use some value, then you should try to take within this range, because common range you should use. Okay, but you can take 100 ratio also, that is also feasible. But normally we will be expecting the common people are using that one. Okay, now PV diagram. So in pumping system you have seen we have cylinder and we have piston. Okay, and oil and gas industry like sucker pump you use the term plunger. Okay, and this one cylinder. Same way I am drawing as pump, this is plunger or piston, this piston rod, and there will be valve system. Okay, V1 maybe, V2 maybe. Okay, so when piston is moving left to right, TDC, BDC, maybe TDC this one, because I said like some clearance must be given. Okay, otherwise it will be hitting the cylinder, so that is not desired because of mechanical reason. And this, if double acting cylinder is there, then there will be some sealing section backside also. Okay, so that piston rod will be moving through the seal. Seal means it will not allow gas to leak through this one. Purpose of seal this one, and another purpose is that seal should not get wear out, so that leaking will start, or it will not give so much wearing of piston rod, it will break. Okay, so purpose will be that you will be giving smooth flow, smooth linear motion of the rod, piston rod. Okay, or connecting rod. So we will have two valves mainly. If we have single cylinder, if you have single acting, if you have double acting, then I will have more valves. V3 will be there, V4 will be there. Okay, there is no specific nomenclature, just I am putting my own name, V1, V2, V3, V4. Okay, and if the piston will have certain amount of leakage, so that leakage also you can consider 1 to 3% within that range. If a very high amount of leakage is there, then you have to change cylinder or piston. Okay, for small leakage like 3 to 5% is okay. For sucker rod pumping also normally we assume that much of leakage. Okay, so any compressor system that much of leakage is allowed normally. Okay, now in pumping system your high pressure fluid you are pumping, there is no compression, but here compression will be there. So how this PV diagram, pressure and volume diagram will be there. This is pressure, pressure. This is volume. Okay, so I am not writing unit. Unit will be later we will discuss. Okay, so let us say it is single acting. Okay, single acting system I am considering. So I do not have this sealing thing. Fine. I have TDC, BDC. So TDC I will draw like this. Here also TDC, top dead center. If I put vertically, then it will be top. Okay, the bottom dead center is to be vertically down. So BDC is here. Okay, BDC. Okay, now piston is moving from BDC to TDC, V1, V2 closed. Okay, V1, V2 closed, and piston moves from BDC to TDC. Okay, so what will happen? The cylinder portion already gas filled, so actually you are compressing. Okay, so compression will be starting. Let us say compression is starting here. Okay, and if you are compressing very slow rate, all the heat will be dissipated because compression heat will be generated, heat will be dissipated. So in that case, it will be PV equals constant, pressure and okay. So PV equals constant if very slow process. Okay, if very fast process, there is no heat transfer, then what will happen? It will happen like this, compression. So normal compression formula. Okay, so here fast process. So adiabatic or entropy constant, not zero, entropy constant. Okay, entropy not changing, but when you are changing heat transfer, so in that case entropy also will change. Okay, now we are compressing, pushing down, compressing. Let us say assume your cycle pumper. Okay, how does it work? So cycle pumper you take manual operation. So initially what you do, you press little bit, then at nearby end you press, you give one jerk. Okay, when you are giving jerk, that time actually air is pushed into your cycle tube. Okay, so that means you have to reach out to certain pressure, then air will be entering. Okay, so when air is entering, that will be constant pressure process, when air entering. So I compressed it, then air will be entering into my cycle tube, that is constant pressure. Okay, so this is called isobaric. Okay, isobaric air entry into cylinder or air delivery. Okay, during compression stroke actually you are not delivering. In cycle pumper also you see, when you are compressing actually there will be no delivery, but when you will be giving, compress it, then give one jerk, so that time you will get some noise also, so that time actually air entered into your tube. Okay, pressure increase, so that will be, we are assuming that is constant pressure process. Okay, initially you are increasing pressure, constant pressure. Okay, then when it compressed, again you are moving up piston, so that time some small amount of gas will be remaining in the cylinder. This clearance area, some small amount of gas will be there because piston is not touching completely. Okay, some gap will be there, so that gap is having compressed air. You compressed it, so some small compressed air. So when piston moving up, that will be expanding actually. So that will be also same process whatever following, like adiabatic is very fast, then it is adiabatic. Okay, so that gas will be expanding. Okay, so that will be, gas will be expanding, it will be coming to atmospheric pressure. Okay, so you press it, entered, then small amount of gas will be remaining in your clearance zone, piston moving up, so the gas will be expanding. Okay, gas expanding, that will be also adiabatic if it is very fast process. If it's slow process, then it will be isothermal. Very fast process will be adiabatic, no heat transfer we will be assuming, so entropy is constant. Okay, so if entropy constant, then S is constant. Adiabatic, if it is isothermal, then it's totally different. Isothermal not possible. Then that is if you want to create isothermal, maybe it will take 2-3 days to move up, because you have to maintain constant temperature. Okay, so you are not maintaining constant temperature, because we are practical engineers. So we don't think that something is possible in 2-3 days. We are moving in oil and gas industry, right? So we have to see approximate result. So some heat is transferred, fine, but our work must be done. Now, when atmospheric pressure, compression, delivery, then again expansion. After expansion, piston moving up, when piston move after certain level, then it will be atmospheric pressure and your cylinder pressure will be same. Outside cylinder, the cycle pumper outside pressure atmospheric, inside pressure atmospheric same. Again you try to move up, so that time inside cylinder pressure will be little bit lower, because you are trying to move up. So lower pressure, outside up, higher pressure will be enter into a cylinder. Okay, so this portion I will put name 1, 2, 3, 4. Okay, so 4, 2, 1 air entry. Okay, so then what happened? V1, V2 closed, piston moves BDC to DC, 1, 2, 2 process. Okay, then 2 to 3, what is happening? 2 to 3 air exit, high pressure. Okay, gas or air. Okay, if you say gas is okay, you say air is also okay, fine. Then 3 to 4, what is happening? Expansion. Okay, now in practical case, actually it is not adiabatic, neither adiabatic, not isothermal. It will be polytropic. Polytropic means some heat will get transferred, because you are approximating everything, right? So you are not making so fast, so no heat will be transferred and everything will be insulated. It's not possible. Cycle pumper also, after pumping, if you touch the cylinder, the bottom side, it will very much heated up. Okay, that means some heat is getting dissipated. Hot, atmospheric temperature lower, so some heat will be getting dissipated. So it is not adiabatic. Okay, not isothermal, not adiabatic. So it will be in between. It is called polytropic process. Okay, so polytropic process means my system will be like this. Okay, polytropic process. So adiabatic process, PV per gamma equals constant. So polytropic also PV per gamma constant, but gamma value will be different. Okay, so adiabatic, so normally gamma value will be 1.4, and polytropic normally PV per n they write, n or gamma whatever you write. Okay, so n value will be like 1.33 or some value will be given. Okay, it will be lower than that. Okay, and if you are making 1, it will be isothermal. If you are making higher, then it will be adiabatic. So it will be in between. Okay, it will be like 1.33. But if you have gas, natural gas, then molecular weight will be also differing. So if when molecular weight is different, the K value or N value will be differing actually. So normally air application, normally we say 1.4 and 1.33. But if you say methane and other gas, in this case gamma or specific heat ratio constant value also will be like 1.28, 1.3, 1.4. That monoatomic, diatomic values also will be different. Okay, so if I want to change the value, then maybe I will give the value, or maybe I will say this is polytropic process. You take this value. Okay. So you understood now single acting reciprocating compressor, how it is working. Okay, it will have one compression stroke, then delivery, then expansion, then suction. Air will be, fresh air will be entering into a cylinder, then compress that fresh air, deliver, again some small amount remaining clearance zone. Okay, so TDC to BDC piston traveling, that is called swept volume. Okay, this volume is called swept volume. VS or VSW, this is called swept volume. Okay, and that small clearance is called clearance volume. Okay, this is called clearance volume. So I can write VC, V clearance, V swept volume, VSW, and total volume. What is the total volume of the cylinder? Actually V1. At the point V1 is total volume, all right. So piston is not delivering total volume actually, some clearance is there, right. Now issue is that okay, I'll discuss later. If I have double lifting cylinder, then in that case same diagram will be there, but for other side, other diagram you can draw, but single side if you can explain, that is enough. Now again I will draw this reciprocating compressor. Piston is here, piston or plunger rod is here, and I will have valve also. I am not drawing, I am making simplified diagram. Okay. Now what happens, let us say you have drawn PV diagram, you have no clearance, then the curve will be like this. Okay, there is no clearance, whatever air you are taking, the same amount you are delivering. Okay, but practically there will be some clearance. So if you are creating very high pressure, let us say this is no clearance, so there is no clearance here. Okay, but when you have clearance, what will happen, piston will move up to this one. Because of this one, okay, you are delivering certain fluid, then you are compressing, and this one will get like this, and you are getting like this, 1 2 3 4. Okay, this cycle will be like this. Now if you want to get very high pressure means P will be going up. Okay, so when P is going up, let us say I make like this. Okay, so you see this I will draw another figure, it's overlapping. Okay, I will draw another figure. So initially I take air like this. Okay, now you want to get more pressure. Say initially you are taking 5:5 ratio RT. Now someone say, no sir, you take 20 RT value, ratio value. Okay, so ratio value means compressing. Okay, now this clearance volume also very high compressed gas, small volume but very high compressed. So when you are expanding, 1 2 3 4 it was initially for low pressure case, but some other student says, Ashish says, okay, no sir, I will take 20:1 or RT value 20. So what will happen, you compress 1 to 2 dash, then deliver 3 dash, then 3 dash when you are expanding, it will come to here 4 dash. So V you see V changed, so intake total amount is changed. Okay, initially you had air 1 to 4, that volume you are sucking, right, but because of very high compression ratio you are sucking small amount, that means total amount of fluid delivery will be low. Okay, so if you increase further air pressure, so that compressed gas part will be expanding further, so intake will be very low amount. So that means your finally if you increase as very 100 psi, so in that case intake will be so low, it will not be effective. Then what is the solution for that? So for that scientists found some solution. Solution is that they will put intercooled multiple cylinders. Okay, how they will put multiple cylinders? Let us say one cylinder is here. Okay, air will be taken, air will be going through this. Again there will be another cylinder. Okay, so cylinder 1 or pump 1, stage 1, stage 2. Okay, stage 1 you are getting certain fluid, that fluid or air or natural gas, because of compression temperature is very high. Okay, so very high temperature is there, high temperature means high volume. If I reduce temperature, volume will be going down. Okay, so performance will be increasing if I reduce temperature actually. Okay, isothermal is better. Okay, if we can reach isothermal, it is better, but we cannot do practically. So that's why they will be putting multiple cylinders. So first cylinder you compress certain amount, then cool it down. So then again you compress, again cool it down, again compress, again cool, again compress. So that way they will be working. Like if you see cycle pumpers they are in hostels most probably, they will have one cylinder, okay, if you watch properly, okay, cylinder, there will be one pumping system here, okay, electrical connection will be there, and there will lots of fins will be there, compression system, fins. Actually there will be multiple cylinder, 2 or 3 cylinders will be there. So one cylinder compressing, intercooler will be there, intercooler means cooling the air, again put that same compressed air to another cylinder, again compress. So 1 to 5 bar you increase pressure, reduce temperature, again 5 bar to 10 bar maybe, okay, instead of going to single compression system. Single compression means it will be taking more energy and performance will be lower. So this will be, they will be putting intercooler. So here one stage, two stage, this is intercooler, okay. So whenever there will be any compression system, reciprocating or centrifugal also, there will be certain intercooler or reducing temperature, okay. If you are not reducing, your performance will be down, okay. Now how to represent this one in your PV diagram, okay. So in single stage case, okay, single stage case PV diagram was like this, this is V, this is P with intercooler, right. So initially curve will be like this, let us say I do not have any clearance volume initially assume, okay. Now single stage this much of pressure P1, P2 we are raising, but some engineers came and they said put one intercooler. Intercooler means after first stage 1, 2 you reduce temperature, this much of energy will be saved actually, again compress, okay. So PV diagram is P into V, P into V actually this area is called energy actually, PdV, you can remember the work formula, PdV, that much of work you are giving. But if you have intercooler, so this shaded portion actually is saving energy, okay. So your system performance will be increasing, okay. If I draw, this will be adiabatic, and isothermal will be like this, because at certain point you are making the temperature almost normal. So isothermal will be going like this, adiabatic this is polytropic, okay. So you understood. So isobaric entry, compression will be polytropic, exit will be isobaric. Isobaric means same pressure, okay. And what will be the in between pressure? So in between pressure formula will be like this. If I have this one P3, if I have P2, so P2 will be P1 by P3. If I have two stage, so normally this is formula you can use, okay. Inlet pressure, exit pressure, multiplication, square root. So that will be in intermediate pressure. The first stage and second stage in between, what will be the pressure? So this will be the formula, okay. For best performance, you can use different pressure also, but for better performance, you can use this formula.